Okay, so one of the properties you know about cosine is that cosine of theta is, it's bigger than or equal to -1 and it's less than or equal to 1. And I bet I forgot to zoom out. I sure did. Okay. But that's for real values.
Yeah.
And you accidentally stumbled into imaginary values of cosine. By the way, what made you interested in graphing cosine of the square root of x?
So I was looking what happens when you change what's inside the cosine, and then I just thought, like I kept multiplying it by numbers, but I was thinking, what happens if you apply operations to it?
Uh-huh.
So I just tried square root of x.
Okay. Cool. Well, to study this, we're going to have to look at it from a slightly different perspective. We're going to have to use the Euler formula, e to the I theta equals cosine of theta plus I sine of theta.
Mm-hmm.
In this case, theta is not a real number, but any complex
It
number.
can be a value. Any value?
Well, it can be any value, real or complex.
Mm-hmm.
So when we put in, like the one we were looking at, when we put in theta equals 7i, so square root of minus 49,
Yep.
we get e. What do we get in the exponent? E to the I times 7i.
-7.
E to the minus 7 equals cosine of 7i plus I sine of 7i. So even here we can see something from this equation. Not a lot, but we can see something.
Well, it looks like the cosine of 7i is going to be in terms of e.
Okay, cosine of 7i is going to have some relationship to e.
Mm-hmm.
Do you see anything else? While you're thinking about it, I'm going to rewrite the equation at the top of the board here.
Well, we've got kind of we have like a two variable equation, kind of.
Okay.
So we can multiply everything by I.
All right, what do you think would happen if we did that?
Well, then these would flip. Well, you'd have I cosine 7i minus sine 7i.
Yeah. And that would equal I times e to the minus 7. But there's something else about this equation which is interesting. This side is a real number, e to the minus 7, whatever that is.
So you know that both of these have to be real.
Well,
or both of them could be imaginary or complex.
okay, and what would happen to the complex parts?
So they'd have to have the same amount of i's.
That's right. So the
Or
real,
I guess they have to have opposite, like negatives.
right, the imaginary parts have to cancel out somehow. And that allows us to use some properties we know about cosine and sine to actually solve this equation. It's kind of what you were talking about with multiplying by I, but we're going to use some different properties of cosine and sine, and we're going to use the property that cosine of x is even. Do you remember what that means? What it means to be an even function?
So it starts. So it's zeros at multiples of pi. Or it's zeros at. It's 1 at even multiples of pi.
Well, that's not the definition of an even function. That's what you know cosine to be. What does it mean to be even?
So something with the graph. The graph of it starts at 1 and goes down, and then goes to -1 and comes back up, and then it's 1 again at 2 pi.
Well, you're referring to cosine here,
Mm-hmm.
but I'm asking you, what does it mean to be even? Lots of functions are even, but they're more than cosine.
There's something to do with like easily reversible.
What do you mean by that?
Like you can reflect cosine over the axis, over the y-axis,
Okay, and what does that mean?
and it stays the same.
Okay, so what does that mean in terms of the function?
So it has the same values, positive and negative.
That's right. So even means f of x equals f of minus x. And you can think about that as being reflected across the x-axis. Sine is odd, and odd means do you know what an odd function means?
So f of x equals minus f of minus x.
Minus f of minus x. That's right. So sine is an odd function. You can also think about powers of simple polynomials. X to the first power is odd, x squared is even, and that helps you understand. So let's go to the third video here and see how we use this.